Okay, and number 17 says the manufacturer of a certain foreign car sold in the United States claims that it will average 35 miles per gallon of gasoline. So it claims that it will average 35 miles per hour. That is stating that the mean equals 35. This is our claim. It says to test the claim, a consumer group randomly selects 40 of these cars. These cars average 28 miles to the gallon with a standard deviation of 9.3 miles, and then alpha is 5%. Well, the mean equals, equal signs always go, and the null hypothesis. So this is our claim, which means our alternative is the complement of equals, which is does not equal. A does not equal in the alternative hypothesis indicates that we have a two-tailed test. In a two-tailed test, alpha gets split in half. So we have 0.025 or 2.5% inside of each tail. Well, this is a large sample because n is greater than or equal to 30, and our critical value is a z-score. In fact, we have two critical values because this is a two-tailed test. So we do the inverse norm of 0.025. And the calculator gives us negative 1.96, but we need both plus and minus 1.96. Now our test statistic comes from our calculation. X bar was 28, mu is 35, S, the standard deviation, is 9.3, and then our sample size, N, is 40, and we get negative 4.76. Now at this point we can already draw our conclusion based on where our test statistic falls. If it falls inside of one of our tails, we reject the null hypothesis. If it is not in one of our tails, we fail to reject or accept our null hypothesis. Well, this number, negative 4.76, definitely falls inside of a tail. So we are going to reject our null hypothesis. However, we should also find our p-value. Well, we have a negative z-score, and we're going to double the area of that tail on the left side. The calculator will give you a number in scientific notation. You shouldn't automatically assume that it is 0, so you should convert to standard form first. Now this to 4 decimal places, actually I'm missing a 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, there we go. Rounding to 4 decimal places, we do in fact get a p-value of 0. Now we already determined that we're going to reject the null hypothesis. The other way to determine is to compare p with alpha. If p is less than or equal to alpha, we reject the null hypothesis. If p is greater than alpha, we fail to reject. Well, p is 0, alpha is 5%. So this is definitely less than or equal to, which means we are going to reject our null hypothesis. Now, in here, there aren't any conclusions to make about the claim. There's no question that is asked. Okay, number 18. A consumer's advocate group would like to evaluate the average energy efficiency of a window-mounted large capacity that is in excess of 7,000 BTU air conditioning units. A random sample of 36 air conditioning units is selected and tested for the fixed period time of their EER recorded below. So here are 36 numbers. It says, is there enough evidence that the average EER is different from would indicate a does not equal. So this would be our claim, and also a does not equal belongs in our alternative, which makes our null equals. So we have another two-tailed test. It is a large sample because n is greater than or equal to 30. We're going to split alpha in half. Our critical values will end up being the same as the previous problem. The calculator gives us negative 1.96, but we need both positive and negative. And then now for our test statistic. Okay, for our test statistic, we have to enter into our calculator a list of numbers. So you're going to hit Stat, go to Edit, you're going to clear out your list, you're going to enter in all of your numbers. Then once you have all 36 numbers entered, you are going to go to Stat, Calculate, and when variable statistics, you can hit Enter if you're in list 1. And we need our sample mean, which is 9.211, or 1 repeating. And then our standard deviation is 0.384. If we go to 3 decimal places, we'll be fine. So our mean, our sample mean, minus mu, divided by our standard deviation over the square root of n, is going to come out to 3.296875. So z-scores, again, we typically round to 2 decimal places, so we're going to get 3.30. At this point, again, we already know what our conclusion will be. We reject if that test statistic falls inside of one of our tails. We fail to reject if it is not. Well, 3.30 is definitely in that right tail, so we are going to reject our null hypothesis. But we can also find our p-value. Now we have a positive z-score, so I'm going to do normal CDF 3.30 to 10, and I want to double the area in that tail because we have a two-tail test. Now we get 9.67 times 10 to the negative fourth. So this is 0.000967. Well, we want to round to 4 decimal places. The 6 is going to round this up to 0.0010. So our conclusion, again, we can also compare p with alpha, even though we already know that we are going to reject. And alpha was 5%. P is less than or equal to alpha. So we are going to reject our null hypothesis. Now it says, is there evidence that the EER is different from 9? Well, we rejected our null, which means we are going to accept and support the alternative. So is there enough evidence to support that it is different from? Yes. So there is enough evidence to support the average EER is different from 9.